So thank you, everyone, for coming to this information session for the Australian Space Architecture Challenge. My name is Amit. I'm the chair of the challenge itself, and I'm based here at the Andy Thomas Centre for Space Resources, which is at the University of Adelaide in Adelaide. Thank you for joining us, and we have a lot of stuff to go through today, so I'm going to get started with all the details, and we will have time for question and answers later. But in the meanwhile, if you need some clarification, please feel free to put it in the chat, and we've got people who are helping with the chat and who can help you or address the question. So thanks, and let's get started. So this year's challenge, it's called Built on the Moon, and I'm going to go through a whole lot of details about the challenge as well, but also the kind of technologies and partners that we're working with. It's a very exciting year, 2025. We've got a lot of opportunities that are developing within the industry and with the Australian hosting of the International Astronautical Congress. So let's hear a little bit more about that. So all the information that we're going to discuss today will be available, of course, through the website. So that's the website address on the top. If you go on the website, you will find that there are 4 sections about the competition, the information for participants, details on registration, and partnering. So all the information is there. Plus, once the registration process is over, next week, we will also hand out the participant handbooks to all the registrants, which will have all the further details as well. So when we established this competition, we looked at the Australian Civil Space Strategy and the Moon to Mars mission and try to understand how we can best support that as somebody who's based out of an academic institution. There's going to be a lot of text on the screen. I'm not going to read all of it, and this will be recorded. So if somebody's interested, they can go back and look at it. I just want to put the stuff on there so that I can highlight the important things that we're focusing on. So the aim of the Australian Space Architecture Challenge is, of course, to work with young people and people who are in the industry and create the capabilities, but also to generally engage and inspire the population to think about space initiatives and what role it plays for us. So yes, it is about application of technology and industry support, but it is also about inspiring people. And I think space architecture is at a perfect overlap between those two things, and which is where we're hoping you will be able to help us. So another aspect of this is international engagement, and I've seen in the registrations we have a lot of international applicants this time, so it'll be great to work with everybody from around the world. But the thing that we want to focus on with this year's challenge is supporting the industry and creating this pipeline or supply chain for the future space workforce and space industry. Before we start with the specifics, there's a few things that we took into consideration when setting up the challenge for this year. So we went to NASA's Moon to Mars architecture documentation, which was published in February of this year. And we looked at certain things that need to be addressed. And there's 3 high priority technology gaps that were highlighted. One is around waste management, which is, of course, an important thing to consider when we are in low resource environments. But there's specific aspects around robotic and human robot inspection, maintenance, and repair. So we can't just design things that will be wasteful. So we need to think about maintenance and repair in the long term and how it can be done through automation and robotic construction. And that is something that we will focus on as well. And finally, the idea of advanced structures and materials to enable these mass efficient habitats, which is the focus of a space architecture challenge. The other thing I really wanted to highlight is this is a very, very special year for us here in Australia because the International Astronautical Congress, which is the largest gathering around space and space industry people, is arriving to Australia later this year. So the IAC, which will be held in Sydney, is from the 29th of September to the 3rd of October. And most importantly, its theme for this year is Sustainable Space, Resilient Earth. So we really wanted to look at how the work that we're going to do in terms of space industry will also help create a resilient Earth. So we are proposing the design of an Australian lunar village, but we are driven by 3 major design imperatives. First is the in situ resource utilization, or ISRU. The idea of ISRU is to build with lunar regolith or locally sourced materials on the moon. This is to reduce supply chain dependence on Earth, but also as a practice in architecture and design to look at how we can work with locally sourced material in general. Another thing that we're looking at, particularly technologically, is the use of additive manufacturing. So using 3D printing methods, using multiple materials, and we'll get into a lot of detail with that as a way of providing the solution. And finally, as we kind of spoke slightly before, waste recycling. So creating the systems that are circular themselves, but also looking for byproducts and waste within the mission and how that can be incorporated into the design of habitats. So if we think through that, it is, of course, a design for the moon, but it also becomes a conceptual framework for thinking about sustainability, autonomous construction, and creating a resilient Earth, which is directly in alignment with the theme for the ISE this year. Before I start about the competition itself, I do want to give a quick background of where we are based and what we do. So we're based at the University of Adelaide. And here we have a research center called the Andy Thomas Centre for Space Resources. We regularly run also the Australian Rover Challenge, which you might have heard about. And I run the Lunar Architecture Research Group here at the Andy Thomas Center for Space Resources, which is focused on looking at creating habitat for extreme environments, but with a particular emphasis on the moon. So yes, there's spatial, operational, and other technological dimensions, but there's a big focus on the human-centered dimension for the lunar settlement. And that is something that we're going to try and promote as part of this year's competition. I do want to sort of acknowledge the fact that this competition is endorsed by the Australian Space Agency, and we've received a lot of support from the Australian government and the Australian Space Agency to make this competition happen. And we continuously refer back to the agenda of the Space Agency to support and improve the lives of Australians, but also the ideas that are being developed as part of the Moon to Mars initiative and the Australian Civil Space Strategy. So you will see these documents referred again in the way we define and develop the projects. So let's get to the actual task at hand. So design brief, this is the overall idea that we are working with. We are projecting slightly into the future, not too far into the future, but a couple of decades in, where the idea of a moon as an industry, as a location, has transformed into something that we are regularly imagining as part of a full structure. So it is the year 2055, and our relationship with the moon is changing quite a bit. So we are not only talking about initial pioneering astronaut visits, but we're actually talking about a permanent infrastructure on the moon, which will be focusing on scientific research, but also autonomous mining and orbital gateways for in the moon's orbit to support such an industry. So we're getting beyond the initial speculative phase to think about the idea of a proper Australian lunar village. So the design challenge for this year is that we're inviting you as participants to envision and develop the central operations and the habitat zone, particularly of a larger Australian lunar village. And what we mean by that habitat zone in context of the overall site, I will talk about it in just a second when we discuss the site for this year. The site itself is on the elevated ridgeline of the Malapert Massif near the moon's south pole. And this is a really important location. And again, we'll give a little bit more detail about that. This zone, this habitat zone that you will design, will form the nucleus of the village, serving as the hub for daily life, strategic coordination, as well as scientific activity. And the aim is that the overall village will allow for long-term operational support for a crew of 150 people. Again, as is very clear, none of this can survive on its own. So the habitat itself is part of a broader infrastructure system, thinking about power, life support, logistics, and communication. And also on the human side, we have to consider the crew's well-being, thinking about the psychological and social and spatial quality of life. There are two things that we need to focus on. We are working with particular industry partners to make this a realistic project. So yes, as designers, we want to be able to do speculative work, and I'm sure a lot of you are interested in exploring those ideas. We don't want you to hold back, but we also want to think about how those ideas can be made into a reality. So we have wonderful industry partners that I'll introduce you to in just a minute. And we want you to incorporate some of those technologies while thinking about your design. So you can choose to focus on one technology, or you can propose a combination of different technologies that might be there. But also remember that when you develop the habitat, try to think of a cohesive, interconnected base there where these things are connected to the surrounding zones as well, as we will see in just a second on the site plan. So like I said, the site for this year is the Malapat Massif, which is a candidate for the landing site for Artemis 3. NASA's Artemis 3 is going to bring us back to the moon, so it is very much possible that that really becomes the basis of such a village. The site itself is a lunar mountain. It is near the moon's south pole at approximately the 86 degrees south latitude, and it rises about 5,000 meters above the surrounding terrain. This elevation also gives it a very, very important position in terms of near continuous solar illumination, allowing us to have access to reliable energy generation through solar power system. And the height also allows unobstructed line of sight to Earth, which makes it an ideal candidate for direct communications. And then also, because it is located near the South Pole, it is close to the permanently shadowed craters, where access to water, ice, and other kinds of deposits, which will be central to the in situ resource utilization, will be available. So it is a very, very exciting site. And as you can sort of see, and we will provide this in the handbook as well, there's a lot more detail and other links that you can use. It's quite close to the South Pole. And then that's the position that you can sort of see. The green boxes you can see are the candidates for the Artemis 3 landing site. And the red box there is the proposed site for the project itself, which is sort of highlighted a little bit on the right-hand side corner there as well. And again, in the participant handbook, there's a lot more detail and links to where you can get information on the site. Once you start thinking about the site, we've divided that into 4 sections. There's, of course, going to be a spaceport where we will arrive, and that has to be reasonably far from the habitat to ensure that there is no regolith which is displaced and disturbs the habitat. This is, again, closer to the Shackleton crater. And as you move along the ridgeline, there is secondary zones for excavation and production of ISRU materials. Then there's a power generation and storage zone, which will support the central operations, and the zone that we are proposing for the central operations and the habitat as well. So again, we can talk a little bit more about these in detail if you want. We have the coordinator here, which I'll introduce in just a second. The important thing that I do want to focus on a little bit over the next few minutes is the technologies that we want you to consider. So before I do that, I just wanted to check very quickly on the chat if there was anything important that I have missed in this sort of introductory part. And you can write these questions, and there will be questions will be answered. But if there is something that you're not understanding in the things that I'm saying, then also put that in the chat, and the coordinator will help me address those questions. So in terms of technologies, we have 4 different construction technologies that we are imagining. And for all of that, we have particular industry partners that we're working with. So the first one, and again, this text is available for people who might want to watch the recording, and it will be in the handbook, but I'm not going to read through it in detail. The first set of partners we're working with is Crest Robotics and Earthwell Technology. And here what we are looking at is using robots for earth bagging construction. So now, what is earth bagging construction? So earth bagging basically looks at local particulate materials that can be used, they can be packed into tubular forms of packaging. Now, this is also being applied in a kind of format of 3D printing, but instead of using a chemical binder, we are using the mechanical system for binding itself. So it's a very interesting project that we are partnering with both Crest Robotics and Earthbelt, and which is supported by the New South Wales government for developing a new robot, which will be unveiled at the IAC this year. So this kind of system can be used. I'm going to try and give you some quick images and a short video for most of these things so that you can get a sense of what they are. This technology kind of emerges from something that we have done in the past. There was an architect, Nader Khalili, in the 1980s who proposed to NASA the idea of Earth bagging, where the idea was that you could use bags, as you can see in the image at the bottom left, and insert a lunar regolith in it and use that for construction. Of course, 1980s was too early for us to start thinking about construction on the moon just yet. But the technology was eventually used by Nader Khalili to establish Cal Earth and to do refugee housing and things like that, as you can see in the image in the bottom left. Structures that come out of that are basically, you can imagine them like a 3D printing component, but instead of a chemical soft set that comes out of the nozzle, here what you end up with is a bagged regolith or bagged earth that is coming out. So the structure might end up looking like the examples that you've got from Cal Earth, the ones you can see on the right as well. And on the top left is the robot that we're working on with the partners. The robot's name is Charlotte. As you can imagine, it kind of looks like a spider, and that's where the name comes from. And we will be unveiling the robot in October. So the idea is to imagine that, and I will let our partners sort of give you a 2-minute video to explain what that is.
At this year's International Astronautical Congress in Sydney, the New South Wales government is promoting a joint venture between my company, Earthbelt Technology, and our friends at Crest Robotics to create Charlotte, a robot for building on the surface of the moon. Charlotte is already being assembled here in the National Space Industry Hub. It's a 6-legged robot that will crawl around 3D printing buildings as it goes. The buildings will be made from Earthbelt, long, compressed extrusions of loose particulate materials, be that lunar regolith on the moon, the iron-rich dust of Mars, or waste materials and Earth right here on planet Earth. It's being pioneered as a space technology, but in truth, it's here to solve our problems on our planet. Charlotte will autonomously process whatever materials can be found nearby to make structurally viable and durable buildings. On the moon, it'll turn regolith into domes, vaults, berms, and pathways and other structures. On Earth, it'll transform earth, mining waste, and crushed demolition materials into homes, hospitals, schools, etc. The great advantage of Earthbelt is that it addresses the ultra-processed construction material problem. The materials that we typically build from, brick, concrete, gypsum board, and even treated timber, are all composite, ultra-processed construction materials, UPCMs for short. To make them, ores are mined and trees are cut all throughout the world. They're fired, bathed in chemicals, crushed and transported, and combined again and again. The energy, logistics, risks and pollution increase with each touch. That's why the cost of UPCMs is so appalling. They cost us 15% of our global GDP, 20% of our carbon pollution, 45.5% of our landfill, and long supply chains that are subject to shocks, which may well occur thousands of kilometres from a building site. Problems that are exacerbated exponentially when the building site is 385,000 kilometres away on the surface of the moon. Which is why an efficient and autonomous robot like Charlotte, which uses only local resources, is critical, not only for a successful space mission, but also to drive the costs of building here on Earth down to something affordable. Our ambition is that the campaign to wean humanity off UPCMs becomes a movement that will eventually save billions of tons of carbon gas and trillions of dollars. But we need your help. If you're interested in designing using Earth-built for the moon or for Earth and want to discuss specifications or wish to work with us in any way, we want to hear more. Email me. I'm Dr. Jan Golombiewski, and my email address is ceo@earthbuilt.tech. ceo@earthbuilt.tech. TECH. Thanks.
Cool. I'm particularly excited about this opportunity because this is something that's being funded by the New South Wales government and something that we will see for the first time in action in October at the IAC. So we would like to see what you as designers could potentially do with that technology. Another technology that we are engaging is, of course, something that you might have heard a lot more about in terms of both lunar and Martian construction, is a large-scale gantry-based regolith 3D printing. This is something that is applied across the world, but here in Australia, we have two major partners that are working with this. So Luton Systems is the manufacturer of their flagship Platypus 3D concrete printer, which can create very complex geometries up to 2 meters in height and width and unlimited length. The application of these Luton printers in terms of actual construction for buildings is being done by a Sydney-based company called Trivima, who we are partnering with. So both developed and manufactured in Australia, this particular technology is a mature TRL9 system that is already being applied for construction and housing, and we want to see how it applies in terms of our lunar context. So again, there are heaps of examples that we can look at globally on where the idea of 3D printing using cementitious materials or using regolith can be considered. This is, again, something that most of you would have come across already. So these is some images of what that looks like. And I will play a short 1-minute video about the particular technology that Luton is using here in Australia, just to give you a sense of what that is. So let me...
These printers or platypus series printers work with cold feeding, which we use the power of chemistry to make an artificial rock. Normally we use molds to do that. Here we use the freeform or the mold-free drawing or 3D printing using that chemical process. So in our technology, for Earth, we don't use any added energy, direct energy input. It's mostly through chemistry. For extraterrestrial, we use an order of magnitude larger energy inputs compared to your, off-the-shelf 3D printer.
Sorry, slight technical glitch there. That I'm just going to move on to the next slide. Albert, can you confirm that you can still see the slide?
No, the sharing is stopped.
Okay. Is that good now?
Yeah, we're back on. Yeah.
All right. Well, sorry about that slight glitch. So of course, Trivima and Luton are our partners for thinking about large gantry 3D printing. And then the third technology that we are really looking forward to is working with the ARC Center for Next Gen Architectural Manufacturing, which is a research center based out at the University of New South Wales in Sydney. And here we are looking at plastic waste recycling through 3D printing. So again, this is a technology that many of you might be already aware of, but it has particular value for lunar habitat systems, mostly because what we are also trying to do is looking at waste that is created in terms of packaging of things that will be sent, particularly in terms of food items and things where there'll be a lot of packaging that needs to be reincorporated and recycled to create a more circular system for habitats and construction. So the technologies of that are something that we can find a lot more in terms of not only Arch Manu's work, but others as well. And there's some really exciting work being done at the scale of the habitat, but also smaller things like building components for internal partitions, for furniture, for equipment housing, and all sorts of secondary structures that are much easier to be built through this plastic recycling rather than things like regolith, which are better off for the external component. So as I said before, you could use any one of these technologies, but you can also use a mix of these technologies. So an external shell could be made out of regolith, but an internal component or furniture could be made out of recycled 3D printed plastic. So for Arch Manu, again, this is an example of the kind of work that they're doing. So this is, as you can see in the image, a wall that is continuously 3D printed using that plastic component, which is recycled from waste materials. But even if you're not looking at a full-scale construction at this of this manner, you could also make bricks or other modular components out of the 3D recycled plastic, which can then be included into your design. And that goes for other components like furniture and partition and things like that. I will try to sort of get through this a bit quicker. There is one other final thing that we want to look at, and that is modular block-based construction. So of course, we did talk about large-scale 3D printing, and that is something that you might have heard about. But why not think about simple systems like blocks and bricks that we are so well aware of already? So here we are partnering with another exciting industry partner, Astroport Space Technologies. Astroport Space Technologies is actually now based in Australia, but originally came out of San Antonio in Texas. And they have this system called the Lunatron 3D construction platform, which integrates regolith refining, thermal sintering, and then autonomous robotic placement. So again, a short 3-minute sort of video, which will show their visualization of how these things could be applied into the future and how we can bring these kind of technologies or normal block-based construction to do other things. So as you can see in the image here, they have an autonomous system using this robot, which extracts lunar regolith and uses sintering here to convert it into blocks, often into pavers and other kind of interlocking systems that can then be used for construction. So very quickly, I'm going to share the video, which is the last video for now, and then we will go through some of the details about the submission and the prizes as well. So that's the last video from Astroport.
Moon travel is back, and with it, opportunities for habitation on our nearest celestial body. Exploration Architecture Corporation, known as XARC, and our subsidiary, Astroport Space Technologies, are developing ways to enable people to settle on the moon and beyond. These new advancements could play an important role in bringing space exploration to the next level. Along with our research partners at the University of Texas at San Antonio, known as UTSA, Astroport has designed equipment that will convert raw material found on the moon into durable material that will be used to build lunar infrastructure. Here's how it will work. On the moon, there's a layer of loose, rocky material covering the bedrock. The bulk of the surface is a fine gray soil known as regolith, which is considered toxic to humans and machinery. It's abrasive and electrostatic, so it clings to spacesuits and gets in gears. And if it gets inside the habitation area, it is a health risk. But that soil also has a good side to it. Astroport has developed high-tech machinery that will ultimately use this regolith as building material to provide solid surfaces for roads or moon landings and takeoffs, accommodating a variety of spacecraft. The first step, create a process for turning the moon's surface material into brick. Researchers and scientists at UTSA are determining the exact temperatures needed to liquefy different combinations of moon soil to turn that melted material into extremely durable bricks. They're also conducting experiments on how much energy is required to melt the soil. Astroport and UTSA researchers have designed a tool called the Lunatron. It's an integrated induction furnace nozzle for forming and placing lunar regolith bricks for the landing pad construction. This machine gets feedstock from the surface, sifts it through a screen, heats it using an induction heating coil to melt the feedstock, then forms it into bricks and places it where it needs to go, all in one step. This technology is particularly groundbreaking, as there is no binding substance required to create the bricks or keep the tiles together once they're placed. Robots, known as brickbots, are deployed to assemble and place the bricks produced from the furnace nozzle into a reusable landing pad. To prepare the surface for the landing pad, an excavator and grader robot smooths over the landing site where the bricks are laid. Then a hauler robot takes the excavated regolith to the brickbot to be filtered and used as feedstock for making bricks. Once the landing pad is constructed, another regolith machine, known as a Rego pack, short for regolith particle acquisition and containment, bags the regolith. It does this in a continuous manner to make long sandbags that are used to build the blast shield needed in case of explosions. When complete, the landing pad will provide a safe landing port that can be used to facilitate reliable and efficient space flights to the moon, Mars, and beyond.
And again, a very exciting partnership and somebody that we've been working with for a long time. Astroport is a really good partner for ADCSR. But as you saw in the video, there's already a lot of work being done with the bricks that they're converting into landing pads. The idea now is to use those bricks as part of architecture and construction for habitats, which is where you guys come in to help take it to the next level. In addition to the 4 technologies, we just want to highlight a couple of other things that are optional explorations. There is aspects of human-robot collaboration that you could think about and see how the humans and robots will work towards the construction process in a kind of semi-autonomous system for construction. Other things to consider is, of course, when you're designing, imagine how the structure might be repaired or maintained so that we are thinking about a long-term sort of sustainable construction. And not to forget the human aspect of the habitat. Please also consider issues around isolation and the psychological well-being of the crew that will be there on the moon, and how we can address that through architectural or design means, and maybe even aspects of medical and emergency protocols of how they could be addressed in the context of this limited resource and constricted environment. Now, very quickly, in a couple of minutes, I want to get through certain important information about how this would work. And what I want is then leave enough time for question and answers to address anything that we might have missed. So very simply, in terms of eligibility, the competition is actually open to any and everybody from around the world. So university students, graduates, or industry professionals from across the world can participate. So it's not limited to Australians. And you don't have to apply individually. You can register as a team. So a team could also have students and industry professionals supporting each other. We actually like and we encourage you to develop multidisciplinary teams. Now, this could be different people bringing in their expertise in engineering and robotics and automation, but also on the human side of it, people who have interests in psychology or health, or other human factors that address these kinds of human habitation needs. In terms of collaboration, we would also encourage collaboration across the board from, let's say, students and industry professionals, because it allows for a better transfer of knowledge and technology. Registration is free, so it doesn't cost anything to register. We encourage all of you, of course, to register. If you are interested and you are joining this session, I'm sure you already maybe have already registered. But if you haven't, please do that. And we have another 10 days for registration, which is open till the 30th of June. So please invite other people to register as well. We also have a Discord community. I will ask Albert to put that in the chat. If you are wanting to develop a team and you're looking for other people to join forces with, join the Discord community and see who might want to work with you and how you can get disciplinary value out of joining forces. In terms of prizes, we have cash prizes as well as support and mentoring in other forms. So there's cash prizes, which is focusing particularly on this year's theme of greater industry integration. So the focus, of course, is using one of those 4 technologies that we talked about and how we can effectively apply these real-world construction technologies into not only space application, but also thinking what value it has for Earth application as well. So we've got a first prize winner for $3,000, followed by a first runner-up as $2,000 and a second runner-up at $1,000. There's a bunch of honorable mentions. We are looking, as we said, we want to support the idea of development of multidisciplinary teams. So there is a mention for an outstanding interdisciplinary synergy in terms of seeing the team composition. If it's an all-student team, we will also encourage an all-student team representing some form of university, and we want to recognize that as the Rising Star student team. The applications that have greatest value, not just for a space, but also Earth impact, is recognized through the Earth Space Impact Award. And finally, not to forget the human experience of the whole design. It is so easy to get carried away in the technological things and forget that at the center of all of this are humans who we need to design for. So people who incorporate and address the human need and the human experience will also be recognized. Finally, I want to go back to the idea that this is a particularly special year for us because the International Astronautical Congress is coming to Sydney, and the winning works will be exhibited as part of the IAC, where we are holding a space architecture symposium. So the Space Architecture Symposium is an official IAC event, which will be held on the Saturday, 4th October. And again, it will include the launch of the new construction robot by Crest Robotics that we talked about, as well as live demonstration and the exhibition of the Space Architecture Challenge. So this event is already available on the IAC website, and people have started registering. So please consider that as you develop your design. So just 2 more slides to go. One is very simply, what is the deliverable? Again, it's a design competition, so we want you to be able to present your ideas in a visual format. What we've decided on is a single A0 size poster in a portrait orientation or vertical orientation that you can submit online as a PDF. We will have a bit later, closer to the actual date of submission, we will open up a folder and you will be able to upload these things. And so the link will be available from the website. And this year, we also want you to put in a short video. It doesn't have to be more than 2 odd minutes, but 2 to 3 minute video where you get a chance to explain the concepts and the key innovation, the rationales behind your proposal. So it gives you an opportunity to add that extra verbal component to the visual poster. In terms of judging criteria, a majority of it is focused on the technical feasibility. So 40% of the score will be on the proposed technologies that we have introduced just before with our partners, focusing on ISRU and waste recycling, and a 20% focus on the human-centered design to ensure that we don't forget in this technological chase that at the heart of all of this is the human experience of living in a very hostile environment. And then, of course, as a design competition, there is a big focus on innovation and creativity in the approach that you're using. So if you're just simply applying the technology but not taking it to the next level, that's not going to be good enough. And finally, because this has to inspire and communicate with a lot of non-technical people, the level of clarity of communication visual presentation is also worth 20%. So I finally want to introduce our wonderful jury team. It'll be led by myself. I am the head of the Lunar Architecture program here at the Andy Thomas Center for Space Resources at University of Adelaide. But we also have in our jury Professor Jane Burry, who is the professor and head of school for architecture and civil engineering here at the University of Adelaide, and a very well-regarded name in the world of architecture, design, and construction, particularly looking at the groundbreaking technologies, which is pushing construction, the sort of frontiers of construction. We also have Associate Professor Urs Better, who is the Associate Professor of Creative Practice at the School of Design and Built Environment at Curtin University, a well-regarded designer himself from Austria originally, but has been based in Australia for a long time now. And from practice, we have two fantastic people. We have Sam Jimenez, who is the CEO of Astroport Space Technologies that we talked about, and an exciting new addition to our jury member panel is Xavier de Castellier, who is the principal and head of design for Hassel Architectural Practice in London, and one of the well-regarded names in as a space architect, having won a lot of competition, including the NASA competition for the design, where he's worked previously with Norman Foster and now at Hassel. So fantastic jury team, and we're hoping we'll be able to go through all your wonderful designs and provide some wonderful feedback. So with that, I'm going to open up to Q&A if you've got any kind of questions that you wish to ask. Of course, you can put these things in the chat, and I'm sure the chat's sort of blowing up already. I can see a lot of sort of red marks over there. But I will also introduce Albert Rajkumar, who's been answering your questions online. And Albert is the coordinator for the Australian Space Architecture Challenge and basically runs everything in the background. And also, you would have received your communication from him via email inviting you to this session if you've already registered. So please feel free to put your questions in the chat. I will try and address them here as best as I can. And also, Albert will keep a record and address others that we can't answer right now via email later. So the question, I'm going to take it up after Albert's comment about the Discord group. And Albert, please let me know if there are previous questions that I should look at. So the question that I can see here is from Murjo saying, can this competition open career or academic pathways in space architecture? Do participants progress into the field? Yes, absolutely. So the idea is that in terms of access into space architecture, this is definitely a pathway, because if you win this competition, not only do we demonstrate this work as part of a general exhibition, but you will also be featured as part of the International Space Architecture Symposium, which is run by the International Space Architecture Technical Committee. And so these are groups which have the top names in space architecture from around the world, including the head of program at Houston and at Munich, and all of these people who come to these events and they hear and know about your project, and that gives you access to that. This year, we're also working with industry partners, and there is a expectation that these people will also serve as mentors for people who demonstrate a capacity to understand the technology and really take it to the next level. So yes, it can really open up those doors. There is a question about how to make the A0 poster engaging and legible. It is not something that I can quickly address right now, but yes, I understand that is something that many of you who might not have done A0 posters would have. So we will try to address that later. Okay. Is it important to focus on the Australian capabilities or global capabilities for technologies? Uh, all the technologies that I've introduced today, they are not necessarily limited to Australia. These are general technologies that are being considered globally for whatever will be viable in terms of a lunar construction. What we are doing is we want to make it more realistic. So instead of generally saying things like, we're going to use regolith as blocks or regolith as 3D printing, we're actually working with particular industry partners who have particular machines and particular details that are being applied to this. So it's only a manner of making it more realistic and addressing it. So instead of saying we will do large gantry 3D printing, we will look at the specifications of something like the Luton printer and see how we can use something like that for our construction. So yes, it is global capacity in that sense, but we're using the specifics of an Australian company that provides that capacity to us.
So can you hear me?
Yes.
Yeah, actually in the chat, I've been deferring the questions to be answered in the section. So there's a lot more questions actually to be answered from.
Sure. So I'll go through the questions as I come across, and then we will go back and address the questions that were asked a bit earlier, okay? So can we get access to these videos? Yes, this entire session is being recorded, and we will put it up on our website so you have access to these videos. Somebody's asked how much of AI we can use for this project. So it will be given as a requirement that you cannot use AI on your final poster. But of course, if you use AI for idea generation or initial conception, I think that is legitimate. A lot of people do that. But your final poster cannot include an AI-generated image or drawing as your final submission. That is very simply a matter of trying to attribute the actual design to you if you are going to be the winner of the competition. Can we add team members after we have registered? Yes, technically you can, as long as you keep us informed and just keep that to the limit of the 5 people that we've said. And again, as Albert has already answered, also make sure that you join the Discord community and ensure that you meet with people who have different capabilities, who can bring that extra quality to your team. Can we make team members more than 5 members? No, we are trying to limit it to 5 members, just so that it doesn't become an unwieldy team where we've got like, a long list of names associated with this. It is a very short time period, and we believe that a reasonable integration or collaboration will only happen with a reasonably small group. Winners access to ISA. Did you mean winners will be invited to the symposium? Winners are more than welcome to come to the symposium, but if you mean that we will fund the winners coming to the symposium, no. The symposium itself is free, and it is taking place in Sydney. If you are in Sydney or Australia, you are more than welcome to come to the symposium, and we would love to have you there. But if you are overseas, I'm sorry, there is no funding to provide air tickets to bring you across. Yeah. Can we integrate terrain data directly from the LROC quick map into our design visual? Yes, of course you can. When we provide you with the handbook and other information also, which is available on the website, we have the relevant links that you can incorporate. Would we need to travel to Australia to present? No, you do not need to travel to Australia to present. It is part of an exhibition where we will be printing and demonstrating the posters themselves, and we will play the video for the people who come to the exhibition. We will try to also take the exhibition well beyond the physical component in Sydney, but there is no expectation that the winners will physically present their work. Your poster should speak for itself, and it is the best way to communicate your design to a broader audience. If we have some of the technologies for real, can we build physical models as well? Or are you looking at conceptual models and renders? I would love to see physical models. My only issue with physical models is when we are trying to run a large international competition, physical models become unwieldy for us to ask people to build, of course, and to access it. So yes, a simple, rendering, a conceptual model or a render would be most appropriate. But if you think that you want to build a physical model and then photograph that and use that imagery as part of your poster, you're more than welcome to do that. And I'm sure some of the jury members will appreciate that effort. But there is no expectation for the majority of you to build a physical model if that is on top of your design process. Are there previous references of such poster? Well, we don't really have references for such poster because this competition and its details are significantly different. But some of the winners from last year's are on our website. So if you want to look at what they did, you can go check that out. However, the brief for last year was very different, and the posters will look significantly different than what you would do for a competition like this one. So I'm now going to go all the way back to the top just to make sure that I have not missed something that we need to address. As a solo participant, what are my chances of winning compared to a team? Are individual entries evaluated with this in mind? Yes, absolutely. As an individual entry, we will look at how and what you are focusing on and how well you have achieved that. When you have a team, the expectation is that you will be addressing multiple aspects of the design challenge. But if you are putting it in as an individual, we understand that the focus becomes smaller, and we will take that into account when we do that. We did have at least one special mention last year who did a fantastic conceptualization for a project, but of course the technical detailing was not there, and we did have one person there. And then one of the other winners from last year was a team of 2 people, so that's not so much more, but it is definitely something that you can do as a solo participant. Once again, however, I will really encourage you to join the Discord community and meet with other people. There are multiple solo participants who are looking to enhance or support their capabilities with somebody else who can bring something to the table. What would a solo entry make specially memorable to the judges? Yes, so again, this is the same for solo entries or also for group entries. If you try to do too many things, but you do it poorly, I think in a challenge or in a competition, that does not bode so well. So try to see things that you can do really well, address other aspects of it, but really try to take one thing that you excel at and bring that forward. If you excel at something and reasonably do other things well, I think the judges will appreciate that more than you trying to address too many things, but not really excelling at any of them. Then there is another question, going back to the question of AI, using AI for the competition. What are the pros and cons? As I've already said, you can use AI as part of your idea generation and things like that. But for your final presentation, images, rendering, drawing, that cannot be AI generated. There are too many questions within that, so I'm trying to figure out how to address that. What is the expectation for the submission format? I think I've already addressed that. And if there is an example, and I also addressed that it is available from last year's winners, but they are slightly different based on the challenge that was given last year. So video submission, what is the expectation for video submission? Yes, so video submission is something that is new this year. So we do not have examples for that. A video submission is like an architectural jury presentation or a design presentation. So it's an opportunity for you to explain how and why you went about what you did. This could be as simple as you doing a video presentation where you're speaking into the camera, or if you want to use things like animation to explain a concept that would not show up on a static A0 sheet, that is where you could really use the video. The format is completely up to you. It could be a slide presentation, it could be you speaking into a camera directly, or it could be an animation, or any combination of those. Roughly how much time do most participants spend researching versus designing? Should we front load research or develop both in parallel? this is kind of hard for us to know because we only see the end product. We don't really speak to the participants about what their process is. But I would suggest that this is due in on 15th of August. So you have got about a month and a half to do that. So I would not spend too much time with the research before jumping into design. I think they kind of need to be done both in parallel to get the most value out of the time that you have left. So, well, actually, it's almost 2 months. So today is only the 20th. So it's almost 2 months, but you would start as early as possible and do both of those things in parallel. How detailed do the construction systems need to be? Do we need to show step-by-step process? No, there is no expectation that you will provide exact construction step-by-step process, but conceptually, because you're incorporating a machine or a technology that we have introduced, what we want to see is that you have considered the possibilities and the steps that are inherently part of that process and accounted for that. So let's say if you're creating a dome, but you forget that to create a dome, you need a scaffolding, then that will not bode really well from a jury perspective, because we would think that you've created the shape, but you haven't really considered the construction challenges that would be for the moon. So no, not a step-by-step process required, but overall understanding of the process and its expression is required. Oh, sorry. Very interesting technologies. Do these design concepts have to cater to terrestrial utility as well as lunar surface, or can it be focused on lunar environment? That's a really, really interesting and important question. As a requirement, no, we do not need you to consider terrestrial utility. However, having said that, the reality is that, as is it with the IAC theme for this year, sustainable space, resilient Earth. The reality is that technologies that we do develop for the space are eventually going to be valuable for us on Earth. Do you need to really develop that for your presentation? No. But after you've developed your design for the lunar context, if you can provide a short reflection on how the things that you have done might be valuable for an Earth application, I think the jury will appreciate that. But it is not a requirement to make a submission. The focus is on the lunar application itself. Are there preferred tools or formats judges find clearer when showing construction systems and ISRU workflows? Do you mean representation tools? I don't know if that is something that is something that is considered. I think in the end, the communication is the main thing. Some people tend to lean on diagrammatic representation. Some people lean on text. Some people do renders. So it is something that you will have to see based on your own capacity and what is the best representation tool you can find. Drawings can be very simple, or they could be highly detailed and rendered. That is up to you. But in the end, it doesn't mean that just because you've used a complex tool for representation that you will be seen favorably. In the end, we are looking for clean and clear communication of the core idea and how it will be translated into a design. What's the most common mistake that teams or individuals make in their submission? Oh, there's a laundry list of that. The one that I will choose to answer in that question is trying to do too much. So yes, you have to be realistic and address the various aspects. So don't forget that in the end, you are designing for humans and there is a human aspect of it. But again, you can't solve everything perfectly. So don't try to make a perfect solution. Try to make an innovative and interesting solution. So choose the things that you can really push the boundaries with, and then address all the rest of the things to a level that is acceptable, but doesn't need to really create a absolutely new solution for that. But really push the boundary of the thing that you want to innovate with, so that the jury can recognize the capacity of what you can do there. So yes, the most common mistake is that people try to do too much and then not really excel at any one part of that. How detailed are the design concepts in the 2 months? Again, look at some examples. You can look with the posters that are on the website. But the design concept really looks at how you're going to apply the technology and what are the overall habitat considerations. So yes, as in any architectural form, we will look at the layout, we'll look at how you have considered the location of the habitat and its relationship to the site, but you don't really need to get down and detail every small little corner. However, if there is a certain particular detail in terms of how you're handling an aspect of the habitat, so for instance, you're focusing on the sleeping quarters as a particular thing, and you really want to get into the detail of the furniture, which is designed using 3D plastic printing, then yes, detail that out and provide broader details on the others. On the other hand, you can look at broad construction processes and think about how you can create a circular construction system so that all waste is reused, or we can create a strongly repairable or easily maintainable structure, which is based on reusable modular components. So depending on what scale you are working at, choose the thing that you want to focus on and design your poster around the appropriate scale for demonstrating that capacity. How is the video versus the poster evaluated? Is the video a pitch deck and the poster for elaborated details? Yes, you could say that. For the majority of it, the poster is the main thing that we're looking at. The video is only given as a supporting idea, which means that things that you cannot get through across as the poster, or where you think you want to just give clearer justification for the position on how you thought about certain things, or you think that if something is not easy to convey in a static image and you need video, then you can use the video. But the poster is the main mode of communication. Also remember, because when we exhibit this at the exhibition, then the poster will be the face of your project. The video will not be available all of the time. So the video is an opportunity for you to communicate to the judges the ideas and concepts that you're working with, but focus on making the poster spectacular so that it can be included as a winning entry in the exhibition. All right, so I've covered all the previous ones, and I'm going to see if there are any new ones that I have not included. I think we've gone through most of it. Somebody's asked to share the Discord link again, so Albert, just please address that. And we've already answered the question about the team members. There is a new question. Can we introduce new concepts which is not available till now? Say like the power source, the oxygen generation, growing food. Absolutely. So if you would have seen, I did talk a little bit about other optional explorations, which means that yes, you are more than welcome to bring new ideas in there, in which case the application of the technology could be simpler. But if you are really considering those aspects of plants or food or power source, then the jury will definitely take that into account. So you can bring those ideas in, integrated with the general technologies that might be required for the habitat construction. Most of the ones that we've suggested can be used in a very sort of simple manner, and you can apply that and then really show your innovation in other concepts that you want to explore. So please feel free to do that. The final question that I can see up there is, can we do design on SolidWorks or somewhat like softwares for representation, or simple drawing representation is acceptable? Okay, I hope I understand the question. The question is that, do you need to use complex design software like SolidWorks, or could you do a simple drawing representation? Again, it is not about the sort of representation technology that you're using. It is about the communication of the idea. So we've had people who do hand sketches and hand drawings. If that conveys the idea better than making a SolidWorks model, absolutely, please go ahead with that. The main concept that you should be looking for is how well are you communicating the core idea and the core innovation. So this is not a competition in terms of representation. It is a competition in terms of applying the idea. If you're using complex structural systems and you want to use software to show the structural performance of your system, then yes, of course, that would be a legitimate use of that technology. But if you are looking to communicate an idea through wonderful hand-drawn images, that would be fine as well. So I would not consider the technology for representation. I would look at what is the idea you want to communicate and what is the best tool you have to communicate that idea. Okay, there's some example about how power can be used. I don't think that is a question, so I will skip that. If the design is just focusing on a waste management system, not covering other aspects, is that also okay? Again, I think that I've addressed before. The idea is if you're looking at waste management, we have already identified that that is a significant part of the things that we want to focus on this year. So yes, of course, you can promote other forms of waste management that we have not included. Things that we have given are our suggestions, but if there are other ways of integrating broader mission objectives into the design, then please feel free to do that. All right, I think we are already a bit over our original time of what we had imagined to be 1 hour. So I'm going to stop this here, and this recording will be available through the website. But please join the Discord community. You also have access to our email. So if you've got any kind of questions, please feel free to contact us and let others know who you might want to include either as your own team member or as other participants, that the registration is open for another 10 days till the 30th of June. So please do that. And please help us also support this by sharing things through social media posts that we put up. And please also feel free to go check out details from the partners that we have suggested. And if you have any questions about that, let us know. We can always connect you directly to the partner as well in case there is some technical question that you want to find out that we cannot address. So that will also allow you to connect with these people in the industry, and that might support your future engagement with the space and space architecture and space construction technologies and industry. So with that, I'm going to bring this to a close. I just wanted to thank our partners again. So please keep a track of those, check those details out, and reach out to us if you have any other questions. Thank you very much for joining the session, and we very much look forward to seeing the competition entries for this year and to having a wonderful exhibition and a presentation of the best that we have to offer at the IAC in Sydney in October. Thank you. Bye.